Alright, in this section we're going to talk about rational exponents. What I mean by rational exponent is when fraction as an exponent. So that means when you have a expression that's going to be as an exponent, it's going to look like as a fraction. So again, an expression that has a fraction as an exponent, or an exponent that looks like a fraction. So given a radical expression, such as the b root, because of the b right here, the b root of x to the 8th power, you can rewrite it as the rational exponent of x to the power of a divided by b. So what's your b root? What's the number outside the root? Will be your denominator. What's the exponent in the inside? Will be your numerator. So here we have two examples. Our first one, the 4th root of m to the 3rd. So if I'm just rewriting it, my only variable is just the m. Now I'm writing my exponent as a fraction, so it's not just going to be 3 anymore. So what I'm going to do first is, since this is the exponent inside according to the rule, that's my numerator, so 3 will be on the top, divided by 4 is my root, the outside number of the root, so it'll be your denominator. So m to the power of 3 over 4. Over here, our second example, it's the cube root of x squared. So our variable is x. Now, I'm using the exponent inside the root, which is square, so I'm going to put 2 on the top, over, and I'll put it over the number that's outside the radical, outside the root, which is 3, so I'll put 3 as your denominator. So x to the power of 2 over 3. So that's our rational root right here, rational exponent. So we rewrote the radical expression to a rational exponent expression. So the 4th root of m to the 3rd is m to the power of 3/4. The cube root of x squared is x to the power of 2/3. Example 3, we have the square root of n to the 3rd. Now, the reason we could call it a square root is because we don't have a number out here. But in fact, we actually have an invisible number, an invisible 2. So when you see a radical with no numbers, it just means it's an invisible 2. So if I were to rewrite this, a radical expression, to a rational exponent expression, it will be n. What's inside the radical will be the numerator. So my exponent inside, that's going to be on the top, over what's outside the radical. So the top left of the radical, so 2 will be up here. Now example 4. So the 5th root of w. Now, if it's just a variable by itself with no visible exponent, then it just means an invisible 1 as the exponent. So, when you see a number or a variable by itself with no visible exponent, it means it's an invisible 1. So, my variable is w. Now, the 1 is inside the radical, and it's the exponent, so I'm going to write 1 on the top over the exponent, the number that's outside the radical, as the denominator, so 5 on the bottom. So the rational exponent is w to the power of 1 over 5, or 1/5. Now in this example, we have the 4th root of x to the 3rd times the 4th root of x to the 7th. So I'm going to show you how we can use rational exponents to help simplify this expression. So first step is we're going to convert into rational exponents for each part. So we have 2 parts right here. So the first one is going to be x. What's inside will be on the top, so 3 as the numerator, over what's outside will be your denominator. Bring down the multiplication sign, write x again, that's our variable. Then what's inside will be the numerator, so 7. Outside will be your denominator, so over 4. So x 3/4 or 3 over 4 times x to the power of 7 over 4 or 7/4. So from exponent laws, I'm going to rewrite it here. Since they're the same base, x, we can rewrite it as x, and our exponents, we're going to write 3, 4. Since it's multiplying, it's going to be plus 7, 4. So the only time we could do this is if when we have the same base and it's multiplying. So in the beginning, if it's the same base and it's multiplying, we combine it as one base and add the exponents. So here, can we add the exponents since they're fraction? Sure we can, because they both have the same denominator. When they have the same denominator, all we have to do is just add the top. So it's going to be x. The denominator stays the same, so 4. So 3 plus 7 will be 10. Now, I can simplify that fraction because 10 and 4 are even numbers, so I can simplify by 2. So it's still going to be x. So 10 divided by 2 is 5, and then 4 divided by 2 is 2. So x to the power of 5 over 2. So if I were to say, give me the rational exponents, this is where you would stop. Or give me the radical expression. So if I were to say radical expression, then you would just go back from this to this. So it's x. What's in my numerator will be on the x. What's in my denominator will be outside. So that's where we would stop. So if I ask you, give me the radical expression, this is where you would stop. Now if I ask you, give me the rational exponent expression, this is where you would stop. Rational exponents and radical expression. So again, convert to rational exponents. Since it's multiplying, we add the exponents, especially when it's the same base. And we got x to the power of 10 over 4, and then we simplify it to x to the power of 5 halves. And if I just say, give me the rational exponents, that's where you stop. If I ask you to give me the radical expression, then you continue to this, the square root of x to the 5th. Alright, in our next example, we have the 5th root of m to the 9th power divided by, or over, the 5th root of m squared. So what we're going to do is we're going to rewrite the top and the bottom as rational exponents. So it's m. The inside exponent will be the numerator, so it's on the top, over the number that's outside the root, which is the 5. So that's going to be our denominator. So m to the power of 9 over 5 over, same variable, m. What's inside will be the top, so 2 as the numerator, over what's outside will be your denominator, so 5. So m to the power of 2 over 5, or 2/5. So we have m to the power of 9 over 5 over m to the power of 2 over 5. So when you have a fraction, what happened is, again, exponent laws, what we're going to do is we're going to write m one time. Since it's a fraction, it's dividing. So what we're going to do is we're going to write the top exponent first, so 9 over 5, minus what's the exponent in your denominator, so 2 over 5. So when we have m to the power of 9/5 over m to the power of 2/5, then we're going to rewrite it as m to the power of 9 over 5 minus 2 over 5. And then we check, can we subtract these two fractions? Yes, we can, because they have the same denominator. So we're going to rewrite it as m, keep the denominator the same, so 5, and then subtract the top. So 9 minus 2 is 7. So the rational exponent expression for this example is m to the power of 7 over 5. Now when we're working with something like this, always be careful if we have an exponent that's negative. Be very careful. In this example, we have the cube root of x to the 5th times the 6th root of x to the 5th. So let's convert that into rational exponent. So on our first one, it's going to be x. What's inside will be your numerator. What's outside will be your denominator times x again. What's inside will be your numerator, and then what's outside will be your denominator. So now let's rewrite it over here for more space. So since they both have the same base, we can combine as one base. So now the first exponent is 5 over 3 plus 5 over 6. Now, our next step is, can we combine these two fractions as the exponents? We can't because they have different denominator. So we have to find common denominator when we're adding and subtracting fractions. So, what's common between 3 and 6? I would say 6. Because the 6 is already 6 right there. So 6 times 1 is 6. Now 3, it can become 6 by multiplying by 2. So what I'm going to do is multiply by 2 on your denominator. Since I multiplied to the denominator, I have to multiply to the numerator also. So when we're changing the denominator, we have to change the numerator. So when we rewrite that, when we multiply top and bottom by 2 so that we can have a common denominator, what's it going to look like is just x. The first exponent will now become 10 over 6 plus, and then bring down the second exponent, second fraction, 5 over 6. Now again, I didn't do anything to this because my goal was to get a common denominator of 6. This is already 6, so I'm not going to mess with it. The only thing I'm changing was the 5 over 3, multiply the numerator and denominator by 2 to get 10 over 6. Now, since they are the same denominator now, all we got to do is combine the two fractions. So it's going to be x, 6 stays the same on the bottom, and then 10 plus 5 is 15. Now, can I simplify that exponent? Yes, I can. The reason is because 15 and 6, the common factor between these two is 3. So I can divide the numerator by 3 and the denominator by 3. So 15 divided by 3 is just 5. 6 divided by 3 is 2. So the rational exponent expression for this example is x to the power of 5 halves, or 5 over 2. So keep in mind, we start off with different radicals and we're multiplying. So the perks of rational exponent is we rewrite it, and then when we multiply, we're going to combine these two exponents, and since they're fraction, we convert to common denominator whenever we add or subtract fractions. We've got x to the power of 15 over 6. We simplify 15 over 6 to x to the power of 5 halves. In this last example, we have the 10th root of x to the 4th power over the square root. Now when you don't have any visible exponent, it's just an invisible 2. The square root of z to the 3rd power. So again, the 10th root of z to the 4th power over the square root of z to the 3rd power. Again, we're just going to rewrite it as rational exponent. So z, what's inside will be my numerator, so 4. What's outside is the denominator. over z. What's inside is my numerator. What's outside is my denominator. Alright, so rational exponents on top and bottom. Since they're both z's, I can also rewrite it as a single z. And according to law of exponents, my top comes first, so 4 over 10. Since it's a fraction, minus. Now, this is my second exponent. It's positive. I'm going to keep it the same. So 3 over 2. Now, we check. Can we combine this as two fractions? We cannot yet because they have two different denominators. So what's the common denominator between 10 and 2? Well, I would say that it would be 10 because 2 can go up to 10 by multiplying by 5, and then 10 is already 10, so I'm not going to mess with that. So when we combine denominators, we focus on what can they be the same by going up. 10, well, 2 can go into 10 5 times, so I'm going to multiply by 5 on the bottom. Therefore, I'm going to multiply by 5 on the top. So, doing so, we are going to have common denominator. So 2 can definitely go into 10 5 times, and 10 can go in itself 1 time. So I'm not going to mess with this. Now what we're going to have is z 4 over 10 minus, then we multiply by 5, so it's going to be 15 over 10. Then continue simplifying, so we're still going to have z. Now, we're able to combine these two fractions because they have the same denominator, so the 10 will be the same on the bottom. So we're just going to multiply the top, so 4 minus 15, that's negative 11. So, since we have a negative exponent, what we're going to do is going to rewrite it where it's going to be a positive exponent. So, since it's negative, we're going to, right now it's a numerator, it's going to bring it down to the denominator. So, it's going to be 1 on top, and then z on the bottom, where it's now positive 11 over 10. So, if I just ask you for the rational exponent, this is where you would stop. So z to the negative 11 over 10 power will equal to 1 over z to the power of 11 over 10.